Good day, this is page 11, number 2 in Advanced Engineering Mathematics of Wiley. So our problem is to find a solution for x squared y double prime minus 6y is equal to 1 plus ln of x. So this form is a Euler-Cauchy equation. So we can let y is equal to x to the power of m, y double prime is equal to m times x to the power of m minus 1, and y double prime is equal to m times m minus 1 x to the power of m minus 2. Then we substitute this to our equation. X squared y double prime minus 6y is equal to 0. We let 0 so that we can get a solution for our homogeneous form, which is our yc. So we can get this form, and then we can get our characteristic equation, which is m squared minus m minus 6 is equal to 0. So we can get m is equal to 3 and m is negative 2 using our quadratic equation form in getting m. Since m is equal to 3 and negative 2, we have our case 1. So therefore we have y1, which is equal to x to the 3, and y2 is equal to x to the negative 2, and we have our yc, which is equal to c1 x to the power of 3 plus c2 x to the negative 3. In order to solve for our yp, or for our non-homogeneous part, we have u1 y1 plus u2 y2, which is equal to yp. So in order to solve for y1, in order to solve for u1, or u1 prime is equal to y w1 over w, and our u2 prime is equal to w2 over w. So our w is equal to x to the 3, which is our y1, and we have x to the negative 2, which is equal to y2, and the 3x squared there is our derivative of y1, or the derivative of x to the power of 3, which is equal to 3x squared, and the derivative of y2, and the derivative of y2, which is equal to negative 2 x to the negative 3. So x to the 3 times negative 2 x to the negative 3, we can get negative 2 minus x to the negative 2 times 3 x to the 2, we can get 3. So negative 2 minus 3, we have negative 5. That is our w. So for our fx is equal to 1, we have 0, 1. Since our fx is equal to 1, then our y2 and our y2 prime, so 0 times y2 prime is equal to 0 minus our f of x, which is 1, then x to the negative 2, so we can get negative x to the negative 2. Then our w2, we have x to the negative 3, our y1, and negative 3x squared, our y1 prime. Then we have 0 and our f of x, which is 1, so x to the 3 times 1 is equal to x to the 3 minus 0 times 3x squared. So our final answer is x to the 3 for w2. Then we can get y1, which is equal to the integral of w1 over w, which is equal to the integral of negative x squared over negative 5 dx. Then evaluate, we can get negative 1 over 5x. And then for our u2, we have integral of w2 over w, which is equal to the integral of x to the power of 3 over negative 5 dx. So we have negative x 4 over 20. Then we substitute it to our formula u1 y1 plus u2 y2. So we have yp, which is equal to the x squared over 4. So for f of x, which is equal to ln of x, we have w1 in our for our yp here. For f of x, which is equal to 1, we left this yp1, so negative x squared over 4, and the yp for fx, which is equal to ln of x, we left this as yp2. So solve for yp2, we have y1 for fx is equal to ln of x, so we have 0 times negative 2 x to the negative 3, so we have 0 minus x to the negative 2 ln of x, so we have negative x to the negative 2 ln of x. w2, we have x to the power of 3 times ln of x minus 0 times 3x squared, so we have x to the 3 ln of x. Then we integrate this using, so we have u1, which is equal to integral of w1 over w, so we have negative 1 over 5, so integral of negative x to the negative 2 ln of x dx, so we can get negative ln of x plus 1 over 5x, and our u2, which is integral of w2 over w, then it is equal to negative 1 over 5 integral of x to the 3 ln of x dx. So we can get these answers using integration by parts by evaluating this. So for our u1, we have negative ln of x plus 1 over 5x, and for our u2, we have negative x to the 4 over 5 times ln of x over 4 minus 1 over 16. Then we substitute u1 y1 plus u2 y2, so we have yp2, which is equal to negative x squared ln of x over 4 minus 3x squared over 16. So for our real yp, we have to sum the yp1 plus yp2, so we have negative x squared ln of x over 4 minus 7x squared over 16. So for our final solution or the final answer, we add the homogeneous part and the non-homogeneous part, which is yc plus yp, so we have c1, so our final answer is c1 x to the power of 3 plus c2 x to the negative 2 minus x squared ln of x over 4 minus 7x squared over 16. So that's it, that's our final answer.